good afternoon, all the participants, distinguished guests, Professor Anurag Singh, sir, our today's speaker for this session, coordinators from MMTTC, and coordinators from my department. We are back after the lunch hour, and for the first session after the lunch, we have Professor Anurag Singh, sir, who is a distinguished academician and professor at Food Technology department in HBTU Kanpur, Hardcore Butler Technological University at Kanpur. So he did his BE and MTech from the same, and even the PhD in food technology before 29 years of his teaching. Sorry, technology with 21 years of teaching and research experience. He is a tremendous have a tremendous expertise in the area of, hello, my screen is flickering. Share me for
Komal ma'am, no worries. Let me introduce myself.
नहीं आया सर आया सर आज सुबह से ही हमारा एक ट्रांसफॉर्मर इधर नहीं काम कर रहा है, तो सुबह से ही चैलेंज फेस कर रहे हैं हम, मल्टीटास्किंग करना सीख रहे हैं।
सुबह से यहाँ पर भी बारिश हो रही है एंड वी आर आल्सो स्ट्रगलिंग विद द पावर कट्स एंड ऑल।
या सो 80 plus of research papers, 30 plus of book chapters and edited books, and more than 20 popular articles with 90 plus of invited talks. So we can understand his dedication in the area of food technology, food processing, and from the talk itself, we'll be able to know that he's a very nice mentor and a trainer. He had been once in the department, and everybody who is belonging to food science background are wanting to work with him. He has guided more than 39 MTech dissertations and supervised 2 PhD theses. Currently, six students are working under him. He has several certification and professional roles at his credit, and few to mention is certified lead instructor for human and animal food. He is NSDC certified trainer for baking as a baking technician and operative for baking technicians and operatives, and FICS master trainer for FME entrepreneurship development. So his main focus is on new product development, tailoring on the fats and plant-based dairy alternative. He is also owner of recognition on the area of Research Excellence Award from Governor of Uttar Pradesh recently. So, sir, with this, I would give you the platform and kindly share with us the topic of Professor Anurag Singh, sir, is plant-based dairy alternatives. Over to you, sir.
Thank you so much, Komal ma'am, for the nice introduction and giving me this opportunity to discuss whatever the knowledge I have with the participants of this FDP. So let me just share my screen. Hope this is visible, ma'am.
Yes, sir. So PowerPoint mode.
Yes.
Yes, sir. Visible.
So it will be very challenging for me to keep you awakened after this post-lunch session. And the topic that has been given for me for the discussion is the plant-based dairy alternatives. This is the university where I'm currently working, HBTU, the Hardcore Butler Technical University at Kanpur, Uttar Pradesh. And this is one of the oldest technical education institution in the country, 105 years old organization. Though the university status was given in 2016, earlier it was HBTI. So those who are in the food tech background, they must be knowing the HBTI. So one of the oldest technical organization in the country. Now coming to the topic for the discussion, the plant-based dairy analogs or the alternatives. So if we look at, there is a market that is booming, that is upcoming, and where we can see various kind of milks or the beverages made of those are similar to the milk or the dairy products. In general, as per the regulation as well, we cannot call them as a pure milk or the dairy products. Rather, they are the analogs. The product, those are mimicking the characteristics, those are substituting the main dairy products in terms of their textual properties, in terms of their sensory properties. Overall, uh, quality parameters, they are being just matched, they are being substituted with these products. So if we define them, so plant-based dairy analogs, they are the non-dairy products derived from the plant sources. Various sources they have been exploited, like some cereals, millets, legumes, nuts, oil seeds, and tubers. They are being exploited. They are being utilized for the development of such analog products. Some substitutions for the conventional dairy products. Which kind of products have been tried to mimic? So it includes the milk itself and the product made of the milk, like yogurt, cheese, butter, cream, or maybe the ice creams. So such kind of products have been made and without using the dairy sources, right? And they are mimicking the products in terms of their appearance, texture, flavor, and functionality. The common raw material that we can see in the market, those are the soybean, almond, oat, coconut, rice, peas, and millets. So some of you must be enjoying the soy milk, particularly that is there in the market. We have seen John Abraham advertising for that particular Soy Fit brand for soybean milk, or many of us might have heard the tofu, the paneer kind of product made of the soybean milk, right? So we have the variety of plant based options, those are being exploited for the development of the milk or the dairy based products. But as I said, we cannot call them as the pure dairy products or the milk. So regulatory authority, FSSAI, that Food Safety and Standard Authority of India, that is the apex body in the country for regulating any kind of food products being produced and sold in the country. So they also mention this category as dairy analogs are the products in which non-dairy ingredients such as vegetable oil or plant proteins partially or wholly replaces the milk constituents while resembling the milk products in taste, texture, appearance, and functionality. So one thing that we need to learn that we cannot plainly call them as a milk. Like mostly in general discussion, we call it soya milk. It cannot be called as milk, right? It must be added with a term called as the analog. It could be the soy-based milk analog or the dairy analogs. And the regulatory authority also says that in this case, it should be made of the non-dairy ingredients and they should resemble with the milk products in terms of the taste, texture, appearance, and functionality. So derived from the plant-based ingredients rather than animal milk, the milk constituents may be partially or completely replaced by the non-dairy ingredients. Now the question comes, when we have the sufficient amount of milk being produced, why we need the dairy alternatives? What is the purpose of this market or this kind of product to be developed? So there are various justifications, various drivers behind the upcoming market of this segment. The very first one is the different kind of allergies that are prevalent, particularly the lactose intolerance. So we can see that in during the early childhood and some late years of our human life, we can see the problem of the lactose intolerance, where the milk cannot be digested by the kids or the aged people. So that is not required now. अपनी चाहिए, सुरेंद्र जी. नहीं. So we understand that the problem comes with the uh, that degradation of the lactose, the digestion of the lactose. and the amount of lactase enzyme that is sufficiently required for this digestion, that is not there in the infants or the old age people sometimes. So we cannot digest the milk. But in this case, dairy alternatives, this is not the problem, because lactose is the sugar that is solely found in the milk only. So there is no problem with the lactose intolerance. Second justification or the factors affecting the growth comes as the health concern. Health concern in terms of the consumption of the saturated fat and the cholesterol. Milk fat, it is having the amount of saturated fat and the cholesterol as well. So there are many people, those are restricting their diet with the saturated fat and the cholesterol. And for that, either they go with the skimmed milk or the toned milk, and they are replacing the ordinary, the full cream milk or the standardized milk. That is again a benefit that comes with the dairy alternatives. We do not have the saturated fat or cholesterol kind of components available in the products. So low saturated fat or cholesterol free diet that is in demand. So for that, these alternatives work well. One another factor is the veganism and the animal welfare ethics. There is a society, a segment of the society that is coming up as the vegan. Earlier, we used to hear that it is the vegetarian or non-vegetarian. Now the concept has come with the vegan, where any kind of animal product that is being avoided, or the people those are working or they are considering the animal welfare, they also avoid animal-based products. So this concept is also supporting the growth of the daily alternatives. Environmental sustainability, if you see, for fulfilling the requirement of the milk for the whole population of the country or even globally, if you see, so maybe that much amount of that much number of the cattle is not available, and if it is there, then the cow dung that is being produced, the methane gas that is being released, so they all also getting the environmental problem associated with. So for that sake as well, if we go with the plant-based dairy alternatives, that can also just restrict or that can also work in the sustainability area as well. Market expansion is there and everything is now accessible. We have a proper supply chain established everywhere in the country. Also, you can see we have the supermarkets, we have the Zepto, Blinkit kind of delivery partners. So everything is readily available. So any food product that you want, that can be just delivered at your doorstep quickly. And functional food trend, we also look for a product that is functional, not only providing the nutrients, but also providing some functional components for the health benefits. So these and they can also be seen in the components in the composition of the plant-based dairy alternatives. So these are some of the factors. They are positively affecting the growth of the dairy-based alternative sector, and that is why we can see many new companies coming up with the products in terms of the milk or different other products, evaluated products made of. If we look at the evolution of the plant-based dairy alternatives, so we can see that the history goes quite long back, and in 13th century as well, we can see the formation of the soy milk in China, maybe the almond milk also in 13th century in Middle East and England. Similarly, the coconut milk was there. Then we see the commercialization in 20th century. Soya dairy was established. Then we see in the modern era the UHT or Tetra Pak processing that can be seen. Almond milk in the packed form that is there in the US market. Nowadays, we can see more options of uh, this dairy alternatives from different kind of substrates that can be seen: hemp, cashew, pea, oats. So such kind of substrates are coming up. So we can observe that the history is quite older, and day by day, gradually, this segment has grown up, and it is now at such a stage where it is very visible and competing with the conventional dairy products. Now, the sources, as I mentioned, we can have the legumes, we can have the cereals and grains, some nuts and seeds, some other sources. Those are being exploited for the development of these alternatives, like soybean, making the milk, yogurt, cheese, or ice cream kind of products. Similarly, the chickpea and other pulses, so they are also being used for the milk and yogurt. Similarly, in case of grains, the oat is there, rice is there, millets, minor grains, millets or quinoa kind of, those are there. In category of the nuts and seeds, we can see the almonds and cashew, coconut, flax or sunflower seeds. So these are being used. There are some blends as well, like legumes and cereals. Those are being used in the blends for making the high protein milks. Some tubers and roots, they are being used, their extract is being used for developing the milk kind of products, right? We can have different alternatives being fortified with the vitamins and minerals, maybe some prebiotic and probiotics, those are also being added. So such kind of sources are there, different categories of the substrates are there, those are being used, and various kind of products are being made in the market. Here the classification, if we see for the products, so majorly we can see the categories of dairy alternatives as the milk alternatives, yogurt alternatives, cheese alternatives, cream and butter alternatives, and the ice cream and frozen desserts. Here also we can see some of the examples of every category where we can have the substrates being utilized. Like soya milk is being made, milk is being made. Similarly, we can see in the market soya yogurt, almond yogurt, and coconut yogurt. Cheese can be made from the almond or cashew or soy. Similarly, the cream or butter alternatives from the coconut, cashew, or soy that can be seen. Those are quite spreadable, creamy, and definitely the dairy free. These are the plant based replacement for the cattle milk based cream or butter. Ice cream and frozen yogurts from coconut, almond, oat, even millets are also being exploited for that. So we can have the dairy-free frozen treats with a creamy texture in different flavors and sometimes fortified as well. Right. So it is now clear that we have the substrates in 4 or 5 categories where the nuts are there, grains are there, tubers are there. So they all can be used, and different types of product can also be made out of these ingredients. Now, key characteristics, if we look at on these products category wise, just a brief. So, milk alternatives mainly, as we see, soy milk, almond milk, oat milk, coconut milk, rice, pea, millet, these are there. What are the benefits that we can get out of these alternatives? So, that comes in terms of being the lactose free and the cholesterol free. That is very prominent because we have discussed the causes, uh, the basic factors, those are responsible for the growth. So lactose intolerance and the people, those are requiring the cholesterol free diet. It is suitable for the vegan and lactose intolerant individuals. Moreover, it can be fortified with the calcium, vitamin D, and vitamin B12 as well from outside by adding different premixes or the fortificants. We can just maintain the required amount of these vitamins. It can be used in cooking, baking, tea, coffee, or smoothie making. Similarly, the key properties of the yogurt alternatives, if we look at, so it is to be made with the fermentation. Creamy texture and pleasant acidic flavor is there. May contain the probiotic for the gut health, suitable for the dairy-free diets. And the categories or the raw materials, we can see the soya yogurt, almond yogurt, coconut yogurt, oat yogurt, or the cashew yogurt being made in this category. Similarly, if we see the cheese alternatives, so soya cheese, cashew cheese, almond cheese, coconut, pea protein, and maybe many more, they are prepared using the plant proteins, vegetable oils, and hydrocolloids. Designed to melt, slice, grate, or spread like the dairy cheese. They are free from the lactose and milk proteins and available in various flavors and textures. So it can easily replace the conventional cheese that is there in the market. Similarly, the cream and butter alternatives, those are being used for the soups, sauces, desserts, and bakery products, having a rich and creamy mouthfeel, prepared using the vegetable oil and the plant emulsifiers, suitable for the vegan and lactose free diets. These are some of the characteristics. And similarly, in case of ice cream, also we can see they are dairy free frozen treats. Wide range of flavors can be there. Those are made. It can be fortified with the vitamins and minerals, and it is definitely increasingly popular among the health conscious vegan consumer. So, ice cream and frozen dessert can be made from the coconut, almond, oat, soy, or cashew, or maybe other uh, milk alternatives that we can produce. Right. So, if we summarize this part, so we can see that different raw materials are there, like soya based, almond based, oat based, coconut, rice based, pea, cashew, millet, flaxseed, ham, sunflower. These all are the sources, and out of that, the studies, those are there in the market, the products, those are there in the market. So we can see different kind of products being made. And one more thing that is important to understand, other than the key characteristics that we discussed in the previous slides, that these products also carry some key back to components. Like, if we look at the soy-based products, we can see the isoflavones, soy proteins, the phytosterols being available. Similarly, in case of the almond-based products, we can see the vitamin E, flavonoids, unsaturated fatty acids. In case of oats-based product, we can see the beta glucan. We can see different phenolic compounds. In coconut, we can see different phenolics or some lauric acid. Rice-based, we can see the oryzanol, particularly different tocopherols is there. Pea-based, we have phenolic compounds. Cashew-based product have the polyphenols, unsaturated fatty acids. Millet is having the flavonoids, fibers, phytosterols. Flaxseed, it has omega-3 fatty acids. Probiotic nature microbes are there associated with. Ham-based product, they have the omega-3 and omega-6. Sunflower, that also have the phytosterol and phenolic compounds. So different bioactive compounds are also there. So they are not only imitating the uh, texture, flavor, or other sensory properties, but these products are also giving you the health benefits because of their bioactive compounds. Those are naturally available, right? So that is why this segment or these kind of products, those are now being popular among the consumer. Those are health conscious. Now coming to the second part, how to make these products, what is the technology, or what kind of technological interventions are being done for the development of these products. So, in general, this is a general flowchart that can give you an overview regarding the preparation of the dairy alternatives, milk alternatives, particularly, and then the value-added products made of. We can have the material that maybe with the shell or without shell. So, if it is a shelled one or without shell, generally the soaking is one thing that is being done. In most of the cases, you will see that soaking is being performed. So soaking is not only making it easy to grind further and get the extraction done, but also it uh, prevents the different kind of anti-nutritional factors as well, that removes different kind of undesirable components those are naturally associated with these raw materials. Right, soaking is done, and sometimes sodium bicarbonate or uh, uh, sodium bicarbonate particularly, that is being added. uh, that also helps in this removal of that astringent nature. Sometimes some anti-nutritional factors, they get reduced by the soaking. So after draining of the soaked grains or the raw material, the blanching or the steam cooking is being performed so that it becomes softened. Then the wet milling is done for the raw material. This wet milling, that reduces the particle size and the extraction becomes easy. Then after this grinding, after the milling, the water addition is simultaneously being done with the grinding. It is being filtered, and after filtration, we get the milk kind of product that we call as the milk analog, right? Desirable ingredients for maybe improving the quality of that dairy alternative, your milk alternative, say some amount of fat or sugar, whatever you want to add to imitate the natural composition. Those are being added. So generally, the heat treatment is given, homogenization is done, and in most of the cases, the aseptic packaging is being performed and stored at a 4 degree centigrade or at ambient as well, because it is a aseptic one, so it can be stored at ambient. Once this milk kind of product, milk alternative is being produced, that can be used further for development of the yogurt, cheese, or butter kind of product. And meanwhile, one more thing, new technological interventions that we see that comes in terms of the addition of enzymes sometime, that also helps to get the better efficiency of the extraction, and we can get better results in terms of the total solids of the milk extracted. So conventionally, what we do, we have these steps being followed: wet grinding, the filtration, pasteurization, homogenization, and fermentation. What these steps are, what these unit operations are. So let's understand the wet grinding. Definitely, the principle is that mechanical disruption of the plant tissues is done to liberate the intracellular components, particularly the proteins, starch, lipid, and different bacterial compounds into an aqueous medium. So water is being added and grinding is being done simultaneously. The process is soaked raw material is ground with water using colloid mills or the wet grinders, and generally we get a particle size of 50 to 500 micron. The advantages are the high extraction efficiency, the uniform slurry formation, suitable for cereals, legumes, nuts, and millets. And the limitation is the high energy consumption. It generates the coarse insoluble particles that requires further filtration. The same we can see in case of uh, we can do in the dry grinding, ordinary grinding. But in that case, if finally we compare the results of the total solids extracted in the milk, that is much lower as compared to the wet grinding. So it is always advisable to go for the wet grinding rather than the dry grinding, right? So otherwise, what we will do in the mixer, we put the material and we grind it, and then we put the water and filter it. That will also work, but the total efficiency of extraction will be less in that case. In this wet grinding, we are soaking the raw material, we are grinding it with the mills, adding the water simultaneously, so that we are getting the better extraction. Second step or the unit operation is the filtration. And the principle in this case is definitely to separate the insoluble fiber and coarse particles based on the particle size. So, what could be the techniques associated in filtration? We can use the muslin cloth, we can have the vibratory sieving, we can have the rotary screens, even the filter press. What we get out of it, we get the improved mouthfeel, the reduced sedimentation, and the product that we get is having a smooth milk like mouthfeel, right? So milk analog that we get, that is similar to that if we are filtering it after the wet grinding. To improve the shelf life, to extend the shelf life, we can go for the heat treatment like we do in case of the cattle milk, ordinary milk. So here the destruction of the pathogenic microbes is to be killed particularly, and some enzymes, lipoxygenase enzyme or peroxidase enzyme, these need to be inactivated so that the shelf life can be extended. Any undue changes does not happen in the milk analog during the storage. So shelf life is to be extended. This is the purpose, right? And for that, different combination of time and temperature is to be optimized for different raw material based milk alternatives. And as a result, we get the improved microbiological safety. The slight amount of protein denaturation is there, but off-flavor development is definitely reduced because of the inactivation of the enzymes, right? So in this heat treatment, we can extend the shelf life and also improve the overall acceptability. Similarly, the homogenization. Homogenization is to reduce the particle size because in plant-based milk, generally the fat component is not there or very less. And if you want to imitate it with the ordinary cattle milk, sometimes the oil is to be added and mixed with the milk analog so that the fat amount can be adjusted, right? So we mix it, but simultaneously the homogenization is to be done so that the oil droplets can be disrupted by the turbulence of the cavitation or the shear forces, and it reduces the particle size. It produces the stable water and oil emulsion that prevents the creaming and improves the viscosity and appearance. The same is applicable in case of the plant-based milk as well as we have in case of the cattle milk. One more thing is there that is done, that is fermentation for producing different kind of variety products. Like we have the controlled fermentation of the plant sugars by selected microorganisms, resulting in acidification, protein aggregation, and development of desirable texture, flavor, and shelf life. So lactobacillus species, those are there, or some probiotic macros like bifidobacterium. Some in the combination they can be used, and in this case we get the coagulation being done, and if we are making the cheese-like product, so that can be made out of these milk analogs with the improved flavor and digestibility. And moreover, the fermentation also works against the anti-nutritional factors and the phytates. So we are improving, we are developing a product as well as we are improving its digestibility and overall nutritional profile. So these are some of the conventional method or the practices those are being followed for the plant-based milk. Whereas some emerging technologies are also there associated with this category of products, where we have the enzymatic hydrolysis, we have the membrane separation, we have high processing, we have ultrasound assisted extraction, pulse electric field, high pressure homogenization. These all are basically to improve the quality of the milk or different value-added products made of that milk analog. So, what are these technologies and what are the benefits? We can have a look on all these technologies, like enzymatic hydrolysis. Enzymes, they work upon the substrates, and particularly if they are splitting enzyme, if they are splitting, they are degrading some of the components in our favor. It means like specific hydrolysis of plant cell wall polysaccharides, starch, and proteins. Because if they are degraded, not degraded, split, they are reduced in terms of their overall molecular size. So they can be easily extracted, and that will add value to the product made of. So we can have the cellulase, hemicellulase, xylanase, amylase, protease, pectinase. These kind of enzymes, those are being used. And as a result of the enzymatic hydrolysis, we can see the increased protein solubilization because protein gets degraded or just reduced in size. Higher extraction yield, we can have the reduced viscosity, improved digestibility, enhanced release of phenolic components. Because the desirable part of the milk or particularly the milk or the extract, what we call, that is embedded or associated with the biomolecules like polysaccharides, cellulose, hemicellulose, or xylose, amylose kind of, and the extraction becomes difficult. Simply soaking or heating or grinding, that will not work sometimes. So we have to degrade the matrix, we have to degrade those compounds, those are holding the soluble material. So in this case, all these enzymes, they work on the respective substrate and they allow them to release the desirable components, right? So we get the better extraction yield if we compare the total soluble solid of the milk analog in which we have used the enzyme for the hydrolysis purpose versus the milk analog that is produced without the enzymatic hydrolysis, there is a clear difference in the total soluble solids obtained. Viscosity is high because pectin sometimes that holds the water portion and it becomes thick. By default, pectin is having a hydrocolloid nature, so it holds the water, and the overall consistency is very thick. And if you want to reduce the viscosity to imitate or to provide a product that is similar to the ordinary cattle milk, in this case, the enzymatic hydrolysis that works well, and similarly, the digestibility that also gets improved. Now, for the separation, we have seen that filtration ordinarily with the help of the sieves or the muslin cloth in the conventional methods. Here, the purpose is to remove the particles with the help of the membranes, right? So, pressure-driven selective separation is being done using the semi-permeable membranes. Different kind of membrane filtration methods, membrane separation methods are being used: microfiltration, ultrafiltration, nanofiltrations, reverse osmosis, that can be seen. And the application is basically for the clarification, the protein concentration, microbial reduction, and partial removal of anti-nutritional components, right? So those are not required in the milk, that can be separated. And but the problem is this can work particularly in the case where the enzymes are being used for the extraction. Enzymatic hydrolysis is being done, otherwise the clogging of the membrane will be the problem, right? So we can go with the membrane filtration as well as compared to the ordinary filtration. For shelf life extension, we can have the thermal processing conventionally, but nowadays there are various other technologies coming up, like the HPP, high pressure processing. In this case, the high hydrostatic pressure is being applied, and that too uniformly through the water on the package. So if it is a package, from all the sides, the same amount of pressure is being exerted, and that is too high. Up to 300 to 600 megapascal pressure is being applied. So especially designed equipments, machineries are there for the high pressure processing. Mechanism behind the success of the HPP is the cell membrane disruption, the membrane of the microbes that gets damaged, they get killed. Enzymes are also getting inactivated, and there is minimal covalent bond damage happens. So there is no as such change in the chemical composition of the components available, or even the shape and size of the product, that is also not damaged with this uniform application of the pressure from all the side. If it is simply produced from the top, from one side only, maybe the package get burst, it will get damaged. But in this HPP method, the pressure is exerted from all the sides uniformly. That prevents the damage to the product, but it causes the damage to the microbes, and they get killed. Enzymes get inactivated, and the shelf life of the product gets extended. And the benefit is, like in case of thermal processing, we have to go with the high temperature for quite a long time, that adversely affect the nutritional composition of the product. In this case, because there is no temperature involved, or if it is a temperature increase, it is hardly 1 or 2 degrees centigrade increase in the temperature. So any thermal damage to the nutrients that does not occur in the application of the HPP. So we can get the better nutrient retention. It's a fresh like flavor that is obtained, and extended refrigerated shelf life can be obtained after the application of the HPP. Similarly, ultrasound can also be used for assisting the extraction process. Till now, whatever the method we discussed for the extraction, in which basically the soaking was done, wet grinding was done, water was being added, and after that the filtration was done. Or to increase the efficiency of the extraction, we discussed the enzymatic application. Different kind of enzymes were applied. But in this case, rather than enzyme, we can go with the application of the ultrasounds, right? So the ultrasounds of 20 to 100 kilohertz frequency, they can be applied. High frequency ultrasounds can be applied, and there is a mechanism. The mechanism is the bubble formation, the bubble collapse, the cell wall rupture, and enhanced mass transfer. So you can just go with the ultrasound mechanism in detail. You can just read it out, and you can understand what is happening, basically what is the whole phenomena. But as a advantage, what we get the increased extraction of protein, the higher phenolic recovery, the reduced extraction time, and lower solvent consumption, right? So simply up, what you do, you put the probe. You can see the probe that is being applied. It is dipped in the slurry. The ultrasound treatment is given. The ultrasonic waves, they work, and this bubble formation, bubble collapse, that is causing the cell wall rupture, and we are getting the better extraction of the nutrients, right? So this could be another emerging technique that can be applied for the dairy analog production. Similarly, for the extension of the shelf life, as we have the HPP, similarly we have the pulse electric field also, where we are applying the pulses of the electricity, so 10 to 80 kilovolt per centimeter microsecond pulses. Those are being applied for short durations, high voltage electric pulses, and they cause the electroporation. Electroporation is again a damage of the cells, so that we can get the better extraction of the nutrients, simultaneously getting the rupturing of the membrane of the microbes, and that is causing the loss of the internal fluids. The cells are getting damaged, right? So increased membrane permeability, improved extraction efficiency, better retention of heat sensitive nutrients, and low thermal damage. In this case also, we are not getting the heat generated. All these are the non-thermal treatments for extending the shelf life or the better extraction, and the same can go with the non-dairy alternatives what we are discussing today. Similarly, the homogenization that we talked, that was there, but the pressure was comparatively very low. Here we are operating at a much higher pressure of 50 to 300 megapascal, right? The principle behind this high pressure homogenization is that high pressure mechanical dissipation of plant particles and oil droplets by shear, turbulence, cavitation, and impact forces, that producing a uniform stable emulsion with improved texture and reduced sedimentation, right? So we can go with a very high pressure for the homogenization. Here you can see the inlet of milk is there, then it is a very small opening, the wall, and then we have the outlet, right? So fat globules or other particles, they are getting reduced to a very fine particle size due to the cavitation, turbulence, high shear stress, and impact forces. And we can get the application of this technology in this case for the nanoemulsion formation, particle size reduction, increased colloidal stability, improved creaminess and mouthfeel in case of the non-dairy alternatives. Right. So the emerging technologies or latest technologies that we discussed, they can be summarized here, and we can see the enzymatic hydrolysis. Mainly, it works with the biocatalysis, and the major benefit that we can get out of it is the increased protein and nutrient extraction. Similarly, in case of membrane filtration, the primary mechanism comes as the size selective separation, and we can get the clarification and protein concentration also done in the case of these milk alternatives as well. Ultrasound can be applied. Acoustic cavitation is the primary mechanism, and that enhances the mass transfer and the extraction. High pressure processing, that is working on the hydrostatic compression of the product from all the sides uniformly. That is basically working for the microbial inactivation with nutrient preservation. Pulse electric field, that works with the on the basis of that electroporation, that also improve the extraction with the minimal heating of the product. And lastly, the high pressure homogenization, shear turbulence and competition is the primary mechanism, and the major benefit that we can get is the stable emulsions and the improved texture of the product. So traditionally, we can produce the milk or milk alternatives or value product, but to improve the overall acceptability, the quality of the product, these novel techniques, non-thermal techniques, or emerging technologies, they can also be used, and we can get a better product being prepared. Right now, coming to the another part where we can just compare the nutritional composition of the products as compared to the traditional cattle milk. So, nutritional aspect of these products, if we compare, starting with the milk and the milk alternatives. So here we can see the cattle milk. We are referring here the cow milk and different kind of milk alternatives. Maybe the soya based, almond based, oat based, coconut based, rice, cashew, peanut, sesame, or millet. So major thing that we need to compare is the protein. If we see, we are getting the 3.5% of protein, and in most of the cases, we are reaching to that level of protein content. 3 to 4, even 6 to 7 in case of soya. Millet is also giving sufficient amount of the protein content. Fat, one thing is, if we are trying to avoid the higher amount of fat being saturated fat, majorly in nature, so we have the lesser amount of fat, except in few cases like almond is there, sesame is there, they are having the higher amount of the fat content. Otherwise, we are having comparatively lesser or similar amount of the fat in the product, right? Similarly, if we compare the yogurt alternatives, in case of yogurt also, if we see the protein, that is again comparable. Fat is also in a comparable range, depending on the raw material that we are using. If it is a 3 to 4% fat that is required, so we have the almond yogurt in the same range, or we are having the soy and oat close by. Cashew yogurt is having higher one. The coconut yogurt is having the higher amount of fat. Protein, again, we can see it is comparable, right? Similarly, in case of butter alternatives, the fat content can be adjusted depending on the type of the raw material we are using. If it is coconut, cashew, peanut, almond, or sesame, so they all are having the amount of natural oil or natural fat comparatively higher than the other plant-based products. So they are producing the butter alternatives with a sufficiently high amount of the fat content, 55%, 45, 65%. Even protein content is much higher as compared to the cattle milk based butter, right? So protein is quite high. Cheese alternatives, in again, if we compare, so fat content comparable, protein is comparatively that can be adjusted. Again, that depends on the raw material, type of the fat, particularly if we look at, so mostly saturated is there in case of the cattle based milk cheese, where we have the mostly unsaturated in different raw materials. Some of the raw materials are there, those are having the saturated fatty acids also there, so they can also be easily compared. So this comparison is placing or endorsing that the plant-based products, they are comparable in terms of the nutrients. Processing technologies, those are supporting that yes, they can be used, and the product that is imitating the cattle milk or the different products, that can be done with the help of the technological interventions. But still, there are the challenges. There are the challenges. Those are to be addressed with the technologies. What are those challenges? We can just see, like the very basic problem that is there associated with the plant-based product, particularly the legume-based product, that is the beanie flavor, a kind of off flavor, right? So the common cause for this legume-based beanie flavor is the lipoxygenase activity. That is the enzyme that works, and it produces different volatile compounds, giving a beanie flavor that leads to the grassy, bitter, or the beanie taste. What could be the preventive approach so that we can reduce this beanie flavor? So here the heat treatment is given to inactivate enzymes. There is the fermentation that can be done to improve the flavor profile, and there could be the flavor masking or the dehydration techniques that can be applied so that we can reduce this beanie flavor. Fermentation and heat treatment we have discussed earlier as well, because this is inactivating the enzyme lipoxygenase particularly, and fermentation is also addressing this reduction. And we can go with the addition of some components or some additives that can mask the overall flavor, right? Similarly, another limitation is the textural problem, like difficulty is there in replicating the creaminess of the milk, or if it is the yogurt, the gel strength of the yogurt that cannot be easily adjusted, or if it is the cheese, we have to adjust the meltability or the stretchability of the cheese, right? Or in case of the amount of protein, because casein that is less, so casein like protein network formation is less, and this we have to adjust. Overall texture need to be improved, and for that there are some preventive approaches, like we can use the hydrocolloids like the pectin, carrageenan, agar, these can be used, uh, that can work with the gel strength formation, gel structure formation, right? Or providing the overall increased viscosity, that creaminess, uniform mixing of the fat that you are adding, or the overall melting that need to be adjusted. So starches can be added, or some emulsifier that works for the emulsion making as well. Fat that need to be added to be adjusted with that cattle milk kind of product, where we can use the uh, oils, or we can go with some structured fats, some oleogels or structured emulsions can be used, that gives the overall better structure to the product. Next problem comes as the protein digestibility. So the problem is because of the presence of the anti-nutritional factors. So we have the phytates, trypsin inhibitors, or tannins; those are available, or that leads to the amino acid imbalance, limiting amino acids like methionine or lysine, depending on the sources. So to address this problem as well, we can have the fermentation, enzymatic hydrolysis, germination and soaking, or blending the legume or cereal together for the better amino acid balance. So anti-nutritional factors can be reduced by these approaches, and this imbalance that is there with the amino acid, that imbalance can be addressed by the blending of the legume and cereals. Another problem or the challenge is the cost and the scalability. So high processing cost is involved, like in case of filtration, homogenization, or the fortification, that is there. Raw materials are expensive. We have the nuts or specialty proteins to be added, or for the large scale processing, a bigger infrastructure is required. That all add to the cost and the challenge for the scalability, right? So in this case, we have to definitely look after the whole economics, and maybe some raw materials, those are less cheaper, they need to be exploited, they need to be explored, and the shelf life, stability, and cold chain requirement need to be adjusted. The technological interventions are needed more, so that we can reduce the overall cost and we can scale it up, right? For scalability, definitely the shelf life is to be adjusted so that it reaches to the larger consumer, because we cannot rely only on the nearby areas. It has to be made available pan India basis or the globally. For that, the shelf life stability and the cold chain that need to be addressed, right? So these are some challenges, but yes, with the help of the interventions in terms of the technological interventions or the policy interventions, these challenges can definitely be addressed. So this slide summarizes all these challenges and the preventive approaches that we discussed so far. Like for the beanie flavor, we talked about the enzyme that is responsible, and for that, the fermentation or the heat treatment that works well and that reduces the formation of that enzyme that inactivated. In case of the texture, we can adjust the texture, we can improve the texture with the help of the hydrocolloids, with the help of the emulsifiers, with the help of the different fat systems. Protein digestibility can be improved by reducing the anti-nutritional factors by the fermentation, enzymatic hydrolysis, or germination. And amino acid imbalance can be addressed by blending the legume and cereals together so that we can get a better amino acid profile. And cost and scalability, as we discussed, for that, definitely the cold chain and the extended shelf life need to be ensured, and we need to explore more raw materials. Those are comparatively cheaper, or we need to look into various technological interventions that can reduce the overall cost of the production, right? So how to mimic these functional properties that we look for? We have talked, we have understood now by now that emulsification will be required, the gelation will be required, foam need to be made, the water holding capacity need to be increased, and the textural development is to be done so that we can get the functionality also from these milk alternatives as we have in case of the ordinary cattle based milk, right? Like emulsification, we can go with the soy proteins, or we can see the oat proteins. They are being used in different studies for stabilizing the oil droplets in the soy milk, or in case of the oat protein and sunflower oil based oat beverages. Gelation, like formation of the 3D protein network that entraps the water and the fat, that could be seen with the help of the pea proteins or carrageenan kind of polysaccharides. So in vegan cheese that have been used, this gelation is required in case of yogurt and cheese kind of analogs, so that can be done. Foaming, that is required where, like in case of the say cappuccino foam on the coffee, we can see the cream is being added or foam is being added. So oat milk that is being used in cappuccino foam, that can give you the desired foaming. Of pea protein based barista formulation have been made because protein is having a natural tendency to provide a foam kind of texture. It forms the and stabilizes the air bubbles. Water holding capacity can be improved. That can be seen because of the protein matrix, soya curd structure in tofu like products that have been seen. It Water holding that also influences the creaminess, thickness, and syneresis. So that can be done with the help of the hydrocolloids. Textural development by using the structured emulsion or the oleogels in different plant creams that has been studied by different researchers. Stretchability in plant cheese by starch protein blends that has been done. So this textural development can be done with the help of the addition of the desired component. So these could be the strategies. Strategy is very simple, that using the biomolecules only, we have to get the desired functionality. So protein or starches or polysaccharides or different emulsifiers, they all can give you the desired texture, desired overall mouthfeel of the dairy alternatives as compared to the milk. Regulatory and labeling aspect for these products, if we look at, so if we compare the dairy products versus the dairy analogs, so regulatory definition is these dairy products are definitely derived from wholly from the milk, whereas the dairy analogs, they are the constituents not derived from milk, replaces the partially or wholly any milk component but resemble dairy organoleptically or functionally. Legal status wise, they products these dairy products are recognized as milk or milk product, whereas the dairy analogs, they are not considered as milk or milk products, but they are need to be mentioned as non dairy or analogs, right? So dairy terms, if you use in this case, that will not work. So they cannot claim or imply to be milk or milk products. They need to be added with the prefix like non dairy or analog kind of products. Ingredient declaration is the standard ingredient listing in case of dairy, but in case of the analogs, it is a mandatory declaration like that it contains what, particularly the non-dairy constituents that is there, or that contains no milk, replace constituent that is there. In case of marketing and advertisement, dairy products they can promote as dairy products, but in case of analogs, cannot create the impression of being dairy. No misleading claim can be made. If used as an ingredient, any dairy product, it mentioned normally in ingredient list. But if any non-dairy ingredient is being used as the ingredient, it must be declared as an analog of, say, analog of cheese, analog of butter, analog of milk, followed by the bracketed ingredient list. Horeca display standard naming allowed, or in case of non-dairy, it is menu must clearly indicate non-dairy or analog before dairy term. For selling, can be sold packed or loose as per category norms, but in case of non-dairy uh, products, it is restricted only packed only in the packed form and more than 500 grams with the proper labeling. So these are some of the guidelines, some of the specifications, legal specifications for the labeling or the display or advertisement in case of the dairy analogs. There are some latest trends in this segment. Non-dairy based products, we have new interventions like probiotic. Like we have seen the probiotics in case of dairy based. Yakult is very common. In the similar way, the plant based yogurt or different products they can also be added with the probiotics. Similarly, the precision fermentation is the new technique that is being used for the development of the casein of vegan cheese, casein for the vegan cheese, because we are not using the dairy product, so we are making the analogs, casein or the way analogs being made, and they are being used in the formulation of the cheese or different valid products from the plant-based milk. Technology, AI or fuzzy logic, this can also be used. That is being applied for the optimization purpose of the processing conditions for these products. Labeling is one thing where the interventions are being done in terms of the clean labeling, where natural ingredients, mineral processing, allergen friendly, such kind of things are being followed, and similarly they are being shown on the labels. Precision fermentation, AI optimization, probiotic yogurts, these all altogether, they are basically giving the product. Those are very close in terms of the texture, flavor, nutrition, process efficiency, or consumer acceptance, as we have from the ordinary cattle milk, right? So some of the latest technological intervention. This slide gives you an idea regarding the products. Those are available in the market under different brand names. So oat based milk, soy based milk, almond, coconut milk, millet milk, yogurts are there, non dairy yogurts. So different products are there. Just a glimpse of few of the products in the market. Now, what we guys are doing at our lab, so some of my scholars they are working on the non-dairy based product or dairy alternatives products. Like one scholar, she is working on the millet-based milk analog, and we are producing the millet milk. Then we are using it for developing the koa analog and using that koa to produce different sweetmeats. So basically, what we are trying in particularly the festive season, we can see that a lot of mawa, a lot of this uh, koa that is being found by the regulatory authorities, those are adulterated, right? And many of us they avoid using any kind of koa-based sweetmeats during the festive season. Just for that concept, we are screening different kind of millets. We are producing different kind of millet milk. So here are the millets that we are using, and we screened them on the certain basis. We analyzed all these millets, millet milk as compared to the cattle milk in terms of the total solid moisture, protein, ash, and acidity. And then we selected some of the varieties, particularly the blends that we used further for the milk preparation. We optimized the process condition for the millet milk extraction. From that milk, we produced the millet milk powder. That was another the part of the study where we were targeting to produce the milk powder substitute. Generally, for the dairy whitener, we can see that pouch of the milk powder is there, and we generally open it and prepare the tea or the coffee. So just to substitute that dairy whitener or the powder, we are producing that milk powder. And similarly, this millet milk powder, as compared to the skim milk powder, it was compared, and we found that in terms of the flow properties, in terms of the overall nutritional values, functional values, the millet milk powder was comparatively better or close by to the skim milk powder. Similarly, as I said, we developed the koa. Basically, here we prepared the koa with the millet milk blends. Different millets were used together, and millet milk was made. And we prepared the koa as we compared it with the ordinary koa, and that koa was further used for the preparation of the burfi. So this burfi was sensorily it was acceptable by the consumer, and it was having the better functional properties. So here we can see the DPPH or TPCs; those are there for the burfi analog. That was comparatively better than the ordinary burfi. Another scholar, she's working on the paneer analog. It is not solely based on one raw material. So we prepared millet and soya based paneer analog. So soybean and millets, they were used in combination, and this paneer was prepared, and that was compared with the ordinary dairy paneer. So textural properties or even the other properties, that was comparable. uh, Fat content was less, so that is one thing that can be adjusted by the addition of the fat if required. And if we are avoiding the fat, as in the earlier slides we discussed, that saturated fat that is not desirable in most of the cases, right? So but texturally it was fine, and it was very close by to the ordinary paneer. So with all the study that we are doing, we published one review paper that was on the millet milk, potential cattle milk alternatives, extraction and value addition in general of food quality. And the research papers, they are in pipeline. Soon we are expecting that they will be getting published, right? So uh, in conclusion, I would say that plant-based dairy alternatives, they are rapidly evolving to meet the consumer demand for sustainability, health, and ethical choices. Functional properties such as emulsification, gelation, foaming, and water holding capacity are critical to replicate dairy-like texture and stability. While nutritional profiles vary, advancement in fortification and protein enhancement are narrowing the gap with conventional dairy. Emerging technologies like precision fermentation, AI driven formulation, and clean label innovation are improving sensory qualities and performance. And the hybrid system, where we are mixing the plant based and dairy together, and the personalized nutrition, represent the next phase of innovation. It is not maybe possible every time that we can 100% replace the cattle milk with the plant based one. So in that case, we can go with the hybrid system. We can also go with the combination, like we can replace the part of the milk that not only will improve the nutritional value, as well as that will also reduce the burden on the that conventional dairy, right? Because the amount of milk that is being produced is not sufficient. That is the very irony, that we do not have the scarcity of milk anytime, though it is a summer season or the winter season. Whatever the milk requirement is there, you just order, and the next day the milkman will provide you the milk. It is very surprising that from where we are getting the milk, because this much production is not there as compared to the consumption that we have in the country, right? So considering all these things, definitely we have to look for the alternatives as compared to the traditional milk, that will definitely improve the nutritional profile of the human beings, right? So finally, the goal of the plant-based dairy analog is not to replace dairy, but to complement it by providing sustainable, nutritious, and consumer acceptable alternatives for a changing world. So this is from my side. Thank you so much for your patient listening. Hope I could have delivered a few of my understanding with the topic. We are also working in this direction and hope the discussion that we had that could have benefited you. Thank you.
Yes, sir. Very nice.
Thank you so
इतने
much, ma'am.
सारे सवाल तो मन में आ ही जाते हैं, लेकिन we give first priority to the participants.
Sure,
So,
ma'am, sure.
sir, I have few questions for you.
Yes.
Dr. Varsha Ben is asking how many % will be added vegetable oil in plant-based cheese, and which vegetable oil is used in such products?
There is no as such a specification that what need to be added. Percentage wise, if you want to exactly imitate the product, the amount of the fat that is there in the cheese or the product you are targeting, accordingly you have to mix. And what kind of oil can be added in that regard? Definitely the vegetable oils, those are very common, so they can be considered. Only thing is you can again see the sensory part. It should be complementing, right? So no as such a specification given.
Okay, true. Dr. Namrata is asking, can millet milk can be used for tea, coffee, etc.?
Definitely, it can be used. And even I would just like to share one incident. There were the samples being made by my scholar, and it was kept in the refrigerator for the study. And the peon in the department, he didn't know this is a sample. He made the coffee out of it, and we all enjoyed. Later on, we got to know it was made of the millet milk, right? So it can easily be
True.
used for the preparation.
Right. Then we have one, Mr. Rahul is asking, can all plant-based milk can be turned into a powder using spray drying for longer period of time?
Yes, drying is definitely can be done for any of the plant-based milk because sugar amount is very less and sticking problem in powders in case of spray drying particularly, because if we go with the cost-effective drying, the spray drying will be better as compared to the freeze drying, right? So there will not be the problem for the drying. Any kind of milk can be considered for the drying purpose.
Sir, sir, my point of view, I would like to know, irrespective of the wet or a dry new food product, this all the mentioned dairy alternatives can be used, or there are specific this type of should be used for cereal based product, particular type of milk is good for a vegetable product and all?
No, ma'am. I think there is no as such compulsion or suggestion. Only thing is, it is our choice. Again, like even if you see that in case of cereals, many of the people they could have their own preferences, which kind of grains they would like. Otherwise, one more fellow, one of my scholar, she worked with the tubers. We use the potato extract as a milk substitute. I couldn't share the details here,
Achha. Okay.
but we tried to extract the potato, and it was giving a whitish fluid. We adjusted the composition with the fat addition and the sugar addition, and we prepared a milk-like product. So again, the raw material can be of the consumer's choice or the individual's choice. There's no restriction as such.
Okay. So, sir, when you prepare such products using freeze drying technology, so for example, cereals based may all bakery confectionery, there you need milk. So, if you want to use this plant alternatives, can that be used, and whether the mouthfeel will differ and the cost will differ?
Cost could be one thing, but when it is on the large scale, it will be comparable. And particularly if it is freeze drying, definitely costlier. Spray drying will be cheaper as compared to that. So definitely go with the spray drying. One thing. Second thing is because the quantity of the milk powder in the bakeries, it is not that high, right? So taste and that can always be masked if it is something there. So with the help of the essence or the sweetness can be adjusted. But the purpose what we have for the dairy powder in case of bakeries, that can be done with the plant based powders as well. उसमें कोई issue नहीं है.
Sir, one thing is whatever last millet milk you showed, very encouraging. But are there any human trials of mouthfeel and product development done on that?
Sensory we did, yes, if sensory we did, but any kind of clinical trials, toxicity particularly, that has not been done.
Not
Sensorily, we have considered the milk, and that is acceptable. That is comparable with the ordinary milk, and that is why we proceed further with the product development, the koa or the burfi. So we
but
proceeded in that way only. It was
so,
comparable.
sir, research review does say that any type of side effects are there, like gaseous distension and
Ma'am, as per our literature, our search, we did not find any kind of such limitations in the consumption of millet-based milk. Even it has been tried with other organizations also. In Niftam Tanjavur, there are some people, they are working with the ice creams made of the millet milk, so they are producing it. In that way, it is being done. And maybe you people are from nutrition side. If there is any suggestion from your side, that is also welcome. We can consider to improve upon in our researches.
sir. Sir, recently the use of camel milk is
Mm.
growing, and
Yeah, yeah.
their powders are also coming up. So, what would be your preference, like using goat milk, camel milk instead of millet milk, or still you would prefer nutritional point of view, millet milk, goat milk or camel milk की
Ma'am,
comparison?
again, yeah. So see again, on what basis we are comparing and what are the factors? If it is a veganism, like very basic concept. If it is a
Of
veganism,
course.
people will definitely not go for any kind of animal milk. And if you compare that composition, so in particular components, camel milk is being shown higher, and that is why it is booming in the market. We also discussed earlier in this regard. So yes, we can go with any of the thing, but maybe the allergies need to be looked into. Individual can have different kind of allergies, different kind of acceptance, and as of now I don't have any comparative study or any clear cut data on all these milk that you mentioned. But when we talk about the plant based, so any plant based we are having, they all are acceptable, and we need to definitely go for it. Mostly the point that I highlighted is the production. Camel milk is very less in quantity. We do not have that much amount of camel milk in the market. Cattle milk is there, cow and buffaloes are there, but still, if you look at the stats regarding the production and the consumption, there is a huge difference. We are not producing that much what we are getting. Everybody is getting the milk, right? But we are not producing. So, to be on the safer side, I would suggest to go with the plant based one.
Okay. Because Rajasthan side says as news mila ki they have lot of camel milk, but the palatability is not that high, so they are converting them into powders and they are giving all different people proposal if they can be used for different product development.
Might
That
be.
is what they are trying
Might
to
be.
give the incentive. And one last thing, sir, can we use this plant milk as a instant milk? One Miss Sri Devi is
Sure,
asking.
ma'am. If we are just drying it, so we are basically making the instant milk only, and it is
Achha.
a dairy whitener kind of product. Maybe we added with some of the sweetener, some of the sugar together, and mixing it so that it can be used directly for the purpose of the dairy whitener, as we have Nestle and all we have.
Okay. Oh, and shelf life also will be high.
Sure.
Want to
If
use
it is a
that.
dried one, then the shelf life is not an issue in any way.
Okay. So thank you so much for your kind
Sir,
guest
ma'am, good
accepting.
afternoon, ma'am.
Yes, Miss Sridevi, please.
Yes.
Yeah, sir, I have asked you, can we use the plant milk as instant milk? Now it has
I
been
answered.
emerging.
I also answered this one already. Yes, we can use it as an instant one, because instant means whatever is not requiring a thorough production or processing. So if we are converting it into the powder one, definitely it can be used as an instant one, right? You made of the
Yes,
powder.
sir, once when we are processing instant milk, no, we are
Mhm.
using agglomerate technology, right, sir?
Right, right,
So
right.
by that, the size of the particles gets minimized. Is it
True.
possible for the plant material to reduce the agglomerate? possibilities?
Yeah, if you are going with the spray drying helps you in the agglomeration as well,
Okay.
right? So go with the spray drying. Definitely, you can get this agglomeration done. In other techniques, it will become comparatively difficult, right? If you freeze dry
Yeah.
it, maybe the agglomeration will be the problem. But with the spray drying, it will be easier. You can convert it to the instant one.
Okay, sir. Thank you so much, sir. Thank you, sir.
Okay.
Okay, sir. Thank you so much for your inputs in the dairy alternatives, and people have initiated the questions, meaning they have considered it as an alternative and will be thinking much more on that. And maybe we look forward for your publications and we get some more ideas into it. Thank you so much. At a short
Thank you
notice,
so much,
you
ma'am.
accepted our
Thank you so much for
invitation.
this. Thank you so much for the invitation. And I hope whatever I could have shared that will benefit all the participants. Thank you so much
So
for the
please
opportunity.
share the PPT. We'll be
I
putting
will,
on
ma'am.
our YouTube channel also your recording once everything is done.
Sure,
And
ma'am.
it
Sure.
will be an advantage to all the participants.
Sure. And lastly, ma'am, I would like to acknowledge, I missed in the slides, I would like to acknowledge my scholar, Suri Pandey, for the work she has done, for the presentation she has made for me, and the work that we have done with the Paneer analog, Miss Pooja Nigam. So these two scholars, they have worked for these work that I presented here, and definitely the HBTU providing the facilities for getting all these done. So thank you so much, everybody, for patient listening, and thank you so much, Komal ma'am, for this invitation. Thank you.
Okay, thank you, sir. Before we start with the next session, few instruction for the participants. Sir, आपको leave करना है तो कर सकते. Each one of you, please enter your name and join the session. Otherwise, the attendance will not be possible because we are not taking, it is taken by the center, MMTTC center. Secondly, we had technical glitches in the morning. So today we are trying to cover up at the end of the session so that tomorrow onwards we are able to give you much more facility. And third and important thing is soon during this lecture, last lecture. So, Farhin Kavita madam has joined. Okay, fine. So we'll be putting the feedback link for today's 3 lecture. So kindly attend those. And